Again, my name is Chris Wright. I am Vice President and Chief Technologist at Red Hat. And I'm here to talk to you about what we're doing to bring OpenStack from the community into real production environments to the enterprise. And in addition to that, I just want to look at some sort of technology spaces and actually talk about some very similar themes to what Jonathan introduced. Hopefully I'll be able to run this laptop here. All right. So first of all, just a step back. What are we doing? We're building clouds, and we've been talking about clouds for quite a long time. Easily, I'd say a decade at this point. Where we are now in this journey to the cloud is recognizing what businesses need to do to remain relevant. And from a business perspective, you're responding to economic pressures. And whether those are disruptive threats, as Jonathan described earlier, or whether they're just straight new opportunities that first mover advantage means you get to realize the benefit of that opportunity. It's these sort of basic economic drivers that are bringing businesses into what some analysts call digital business or digital transformation. It's really about looking at your infrastructure from the perspective of your specific market vertical requirements, and whether that's the retail industry, logistics, public sector, finance, telecommunications. All of these different industry sectors have some specific requirements that they're trying to realize the economic advantages of changing their infrastructure so that they can adapt quickly to the moving business reality around them. And I think that's kind of the core tenet of a cloud. I think we've talked about that a lot. It's about automation. And so some of the context for OpenStack is we're building a cloud and we're trying to light up this infrastructure to enable these economic, enable businesses to react to the economic drivers. We did a survey with Harvard Business Review that showed three key themes on the minds of CIOs, really. And the first theme is they're trying to drive core innovation through IT. So what I often say is the IT department in a business is transitioning from a cost center to a fundamental technology differentiation or business differentiation built around technology. And that's a new shift. That's a trend that is exciting if you're in the infrastructure space in your company, and it's what we're trying to enable when we're building a cloud. Can't do this without keeping in mind risk and security. So this is top of mind to CIOs, especially when we've had some high-profile security vulnerabilities, and you hear a lot about moving rapidly. You think about a traditional business which is primarily focused on managing risk, often risk-averse in risk-averse sectors of the economy, heavily regulated, whether it's financial institutions or telecoms, where they're really focused on managing change, which in many cases means putting up some form of obstacle to change. In order to facilitate this sort of next-generation infrastructure and still kind of manage your risk profile and manage change, the CIOs are talking about building standardized architectures to build up this next generation infrastructure to support the digital transformation. So as Jonathan mentioned, and we've experienced quite a bit at Red Hat when we're working together with our customers who are trying to do OpenStack deployments, there's maybe a myth that you build a cloud and they come. And so you stand up these clouds and you see that awesome statistic that you went from 44 days to 42 days in rolling out new services. You realize that it's not just the technology component that's critical in building out a cloud. It's also the people, process, culture, all of these things that are really the obstacles are blocking that rapid change that you're trying to build your business from. And so you hear concepts like small cross-functional teams, the two-pizza team as an example. That's a very significant shift in how you might internally align your developers and your operations people to build and deliver applications. All of these things are representing cultural and people and process changes that are actually quite a bit harder than the technology shift. So we're building awesome technology all the time. How do you make it realizable within your industry or within your business? That's a harder problem to solve. And when the people, process, culture piece is not really solved, the technology gets the blame. So I don't know who here has deployed an OpenStack cloud and found it complicated, difficult, and you look at your people, process, culture around that, probably that wasn't what took the blame. It's probably the technology itself. So in this context of IT needing to evolve to meet the digital business demands, I kind of break it down into 4 different categories of IT evolution. And in one dimension, you have just the development process. How are you building and developing your applications? And we've started off with a waterfall methodology, which I was speaking with somebody yesterday, and I got tongue-tied and called it water flaw. So I think I like that, the water flaw development process. Move on to Agile, and currently we have DevOps, where you're really fundamentally changing how rapidly you can introduce change into your application. The application architectures themselves are changing, so we started with monolithic applications. We did some initial work on doing distributed computing, and you have client-server or multi-tier applications. And today, a lot of the interest in the industry is around microservices, sort of the next generation or evolution of this distributed system that is a modern application. In another dimension, we have how are you building and delivering the actual application? So at one point in time, it was sort of one application per server. So the server, the operating system, the application, they're all bundled together, and that's your pet or your special snowflake. You're actually afraid to touch it. You don't have great automation around managing it. So it's the one administrator who knows that box is going to administer that box, and nobody else is comfortable touching it. We evolved into taking that same concept and putting it into a virtual machine. So now you had some APIs and automation around how you might lifecycle manage the virtual machine itself, but you still have some of the concerns of what's inside the VM in terms of the pet versus cattle analogy. And then modern applications, you hear a lot of conversation around containers. So containers being just a really lightweight way to combine both your application logic and its direct dependencies and deliver that without requiring the entirety of an operating system or any of the additional runtime environments that you might be able to inherit from something underneath. In the application infrastructure piece, which is really where we're focused on with OpenStack, we've evolved from standard own your own data center, maybe some outsourcing and hosting of data centers, to running things in public and private clouds. So at the bottom of that picture of IT evolution, you've got DevOps, you've got microservices, you've got containers, you've got cloud. All of these things together give you the ability to rapidly introduce change into your applications and deliver new functionality really at the pace of your business requirements, not at the pace of your internal processes. And what's interesting here, I think, is a big component that's standardized across each of these is APIs, allowing for automation, which means you don't necessarily have to consume all of these at once. So you could adopt a DevOps model, delivering things in virtual machines. You don't need to shift wholesale your infrastructure as the only mechanism for realizing that speed or agility. So here's maybe a new way to look at success metrics for CIOs. First of all, we're trying to respond quickly to business needs. So that's agility, and we've talked a lot about that in the industry. I think that's a pretty common, well-understood theme. There's also a component of satisfaction, high customer satisfaction. I mean, a lot of the applications that are being developed today are directly visible to end users. End users are, well, we're fickle, right? You've got your phone, you're working with an application. If it's not intuitive or if it's slow, you just move on to the next one because there's a lot of choice. So that's both a threat and an opportunity from a business point of view, from the CIO's perspective. And then while you're building up your applications, you need to retain some level of confidence that you can actually deliver what you're promising on, whether that's from a security point of view, whether it's performance, scalability, all of these kind of traditional KPIs that we've been measuring for a long time in traditional applications are even more relevant today as you're sort of abstracted away from some of the layers below you. So agility is one that I think we can measure in terms of developer wait time. And I think of it in terms of a developer waiting to do something. So an idle developer, application developer, is kind of a dangerous thing. That's sort of the birth of shadow IT. So you're waiting, you've entered your trouble ticket to get just a basic virtual machine, and 2 weeks later you finally get the VM and you know that it just takes seconds to actually boot the thing. That's frustrating. So where can you improve your process to respond quickly to developers' requirements is really at the root of agility, and you're trying to get away from creating obstacles and forcing developers to wait for portions of the infrastructure to be available. And I think the question to ask yourself is, if everything is changing, change is the one constant, how can you build your systems to accommodate that? I think of it in terms of eliminating friction. So at every stage of development, deployment, doing analytics and sort of the repetitive loop of refining and improving an application, at every step of the way, there's an opportunity to reduce some friction. Could be through automation, could be through improving your process or taking an existing process and putting it into your automation framework. These are ways that you can really speed up your overall application development and delivery cycle. If you look at it from the point of view of a delivery pipeline, an assembly line of sorts, traditionally we have a lot of specialization within the organization. So you've got your storage teams completely siloed from your network teams, completely siloed from your DBAs and your operations teams, all kind of running in parallel universes. And that means to get one thing done, you have to go touch each of these individual teams. Every sort of handoff from team to team is an expensive operation, and that's where you're waiting. That's where there's people involved. That's where you're asking a human to do a thing rather than using APIs to request something. So there's not self-service. There's maybe a handwritten sticky note on somebody's monitor because the DBA is out sick today. And what that really translates into is this large request queue that's backing up and causing people to stall and wait. And that is exactly what we're trying to avoid. The other dimension is customer satisfaction. Customer satisfaction is in terms of performance. That's your phone and it's your application, and you're waiting for a web page to load and it's slow and you give up. If you don't have the right feature set, you're not competitive. You really aren't going to attract users. More importantly, modern applications are looking at sort of how can they delight the user? How can they be intuitive? Not easy to use. There's, especially in a phone context, there's very minimal screen real estate. So you're trying to engage the user in a way that's not only new, but we're learning from metrics that you're drawing out of your application to recognize how changes in your application affect user behavior. So this is really an interesting and new way to look at customer satisfaction, and it's important. Backing all of that, it's important that you're able to rapidly roll out changes to your application. What does it mean to be confident to deliver within your infrastructure? These are sort of some standard set of performance metrics or KPIs, performance being one of them, which is from an infrastructure point of view, you want to be confident that you can deliver not just a single app, but a collection of applications that may be competing for resources in a way where they're going to continue to deliver some kind of a consistent performance metric or meet an SLA. Associated with that is availability. We're familiar with kind of modern applications building some of the availability intelligence into the application layer. So you have load balancers, you have applications that are aware of faults in the system so they can self-heal or repair themselves. We can't forget about security in this environment. So who's responsible for the different components of the system, and where security comes from is it's front and center because of the high-profile vulnerabilities that we've seen recently. And as you get a more and more complex system, it's less clear who owns the responsibility for securing your system. And clearly, we're talking about cloud, so you want to be able to elastically scale up and scale down your application in response to real live traffic or user demand. So the infrastructure for digital business, you might be able to look at it in these 4 different dimensions. One is something that Jonathan was talking about, is looking at standardized resources, and that's the standardized resources or platforms or whether it's hardware or software. That's what allows you to operate efficiently. You have a well-understood way to manage a thing, whether that thing is an application, its application lifecycle, or whether that's your infrastructure and you're lighting up storage or networking. If you're able to do that in an automated way, that's where you'll be able to be quick to respond to business requirements. That sort of pipeline of specialization that causes wait times is something that we need to look at and sort of refactor where specialization sits in the stack. So we want to be able to facilitate autonomous decisions within a domain. So you don't have to cross a domain to get something done. And if you do, that should be an automated request, not a direct personal walk across the hall or something that can really create the wait time. And we're looking at from a developer point of view, this is automation driven through self-service. So you're able to procure the resources you need to build and deliver your applications. And the infrastructure underneath we expect is like a utility. It's always on. It's a managed service. From an application perspective, it's just providing you resources, and it's not something you really care deeply about the implementation details of. So this is all about applications. It's all about the delivering business value through an application, responding to business requirements quickly. The applications are built on, traditionally, hardware. So somewhere in there's a CPU, there's I/O, there's real physical hardware supporting the application, and there's a well-understood abstraction layer that we've had for years, the operating system, giving you resource management of the hardware underneath. So traditional stack that we all know and love. A modern stack, a cloud, looks suspiciously similar, but now we're distributing this concept across an entire data center. So you still have hardware at the bottom. You've got infrastructure that you're managing with an infrastructure layer that's compute, network, storage. You have this middle layer, which is doing some level of resource management and the ability to sort of give you a sense of, or give applications certain services or runtime environments. And then at the top, you still have traditional applications, the direct application dependencies. And this is sort of the modern cloud stack. And I think what's interesting here is we often think about a cloud, at least I do, because I'm more of an infrastructure person, from the infrastructure layer. But the perspectives really matter. As an application developer, as I said earlier, you're looking at how quickly you can build, deliver, deploy your application. You're not really all that fussed about what's underneath and how you're managing the infrastructure, as long as there's APIs so that you can get self-service automation to manage your own needs. From the infrastructure point of view, you're looking from the bottom up. You're trying to manage hardware. You're trying to meet a whole set of application requirements. And so, we really have these differing perspectives. So if you look at an ideal cloud, you can sort of categorize it into these 2 different personas, one from the developer point of view and one from the operations perspective. The developer is looking at their application lifecycle, how quickly they can get services scaled up and scaled down. From the operations point of view, you're looking at how efficiently can you manage all of this infrastructure? How are you maintaining insight into what's running, security compliance, kind of a different set of concerns. And, together, it's those sort of different viewpoints that really build up a cloud. And so taking that from just the abstract and high-level business digital transformation jargon to what's really happening is we're building OpenStack. We're taking OpenStack to customers. Customers are powering their infrastructure with OpenStack, and it's helping them transform their businesses. So let's look a little bit at making it real. So Jonathan mentioned that some of the stats from the user survey, the OpenStack user survey. If you roll back 2 years ago to, it's not on the slide, but to May 2014, the user survey resulted in about 33% of the respondents deploying OpenStack in production. So if you fast forward 2 years, we have nearly 2/3 of the respondents putting the OpenStack into production. So that's a 2x improvement over 2 years with a nice steady growth. So we're really seeing OpenStack maturing into production. This is a small subset of Red Hat specific customers. So I call it logo eye candy. It's just a small subset of our customers. We're serving hundreds of customers with OpenStack at this point. But one of the things that I really enjoy about this kind of a picture is it gives you an immediate sense of the diverse set of use cases that we're meeting demand for with OpenStack. So it's, as Jonathan was talking about, diversity is important, and understanding different use cases is what helps us grow and change OpenStack to be something that will continue to solve new problems that we don't even understand we have at this point. So I'll walk you through a couple of quick examples. FICO is a customer that's deployed OpenStack. In their deployment, they've been able to reduce, well, initially, FICO for me is the credit score company. They're a more broad product portfolio than that. What they're really doing is building analytics tools to help their customers make smart business decisions. And they've built this solution set, delivered it to large organizations as an on-premise offering. And that's an expensive endeavor for their customers, and it means that it's a slow cycle for them to add new functionality to their platform. So they wanted to look at how can we sort of attract small to medium businesses and be able to roll out services more rapidly. They moved all of their functionality to a cloud, so now it's a hosted service. And with that, they've been able to reduce their time to market of their new solutions by 50%, while also reducing their total cost of ownership by 30%. From a user of their platform point of view, users are able to consume these analytics solutions and make sort of business value decisions for the users' companies in a significantly reduced time frame. So the sort of time to value is also reduced. So we're looking at OpenStack helping a business tap into new markets, move more rapidly, and reduce costs. So it's kind of all goodness, which I think is an awesome example of a community collaborating to build software to help transform business. Betfair is another example. One of the largest online betting systems and the largest online betting exchange. They've recently introduced OpenStack as part of their platform in this I2 program. The I2 program's goal is to move their core exchange platform plus associated about 200 microservices that build up their application onto the cloud. And with this shift into an OpenStack deployment, they're actually impacting millions of users a day in terms of transactions that are going through this betting system. And again, it's OpenStack, it's the community collaboration that we're doing together here, impacting these businesses that are touching the lives of millions of people. Verizon, as you heard about in Jonathan's talk just before me, like AT&T and like other service providers around the world, they're fundamentally transforming their network from a collection of bespoke, hardware-centric functionality to a generic compute network storage platform hosting that same network functionality and software with all of the flexibility that comes along with a software-defined infrastructure. Verizon started roughly 9 months ago on a journey to introduce OpenStack, and within a 9-month period, they were able to roll out OpenStack across 5 data centers, really the beginning of them virtualizing their network, building their next generation network. So this is a very significant change for traditionally an industry that moves relatively slowly and retools itself about once a decade. Here we are in this retooling cycle for the telcos, and OpenStack is the tool of choice. So this is a great opportunity for the OpenStack community, and also just a really interesting way to apply OpenStack that when we started on this journey, building a cloud, we weren't thinking at all in terms of satisfying telco requirements. So in each of those kind of examples, there is upstream community development that's happening. So whether it's OOO heat templates to improve the deployment, or whether it's IPv6 functionality end-to-end for services and through Neutron, this is functionality that starts in the community and slowly percolates out to real end users. And this is something that Red Hat does first as a vendor, working with our customers and partners, understanding real-world use cases, translating those into blueprints and code, working then with the community to upstream and merge those changes necessary to meet those requirements. And again, this is the community process. This is exactly how we work together to make software accessible to the enterprise or to service providers. So I wanted to touch on diversity. All of those different logos, the few different examples that I gave, they represent a really diverse set of use cases. And to me, that's actually one of the most important things that we can look at from the OpenStack point of view. If we have a narrow definition of what a cloud is, we will be constrained by that definition. So we really need to look at how do we grow and adapt and shift the infrastructure to support a wide set of diverse use cases. If you look at something like Linux and the success that Linux has had, it's ubiquitous. And its ubiquity, it's on, it's in the world's largest supercomputers, it's on your phone, it's in your car, it's in your TV, it's responding to all the queries you're making on the internet. The ubiquity is the result of sort of a slow but measured evolution responding to new and different use cases, whether it's porting to new architectures or whether it's scaling down to a small system or scaling up to a large system. This is really the power of community collaboration and that ubiquity, something that we're looking for with OpenStack in this kind of distributed operating system in the cloud. The more use cases that we can satisfy with this infrastructure that we're building, the more we're ensuring longevity for the platform, and we're going to improve, sort of by just requirement, we're going to improve the core infrastructure at an architectural level. So we're not just adding features, but every feature needs to be added in a way that we're careful and thoughtful and thinking about the long-term impacts of making the changes to this platform. And that's what makes the system sustainable, maintainable, and able to evolve and meet new needs that cloud needs that we don't even understand today. I was talking to some researchers about a few months ago, and they're focused on something they call cloudlets. So the IoT sensor space where you have really minimal processing power at the edge, you have an immediate first hop. That could be a small cloud in your car. It could be a cloud right at the edge of the mobile network. These are places where you might have new forms of applications that we're just now starting to imagine and seeing become real with things like self-driving cars and augmented and virtual reality. Things that are happening today we weren't necessarily planning for at the beginning of building a cloud. And again, it's that diversity that helps us sustain the project. Another thing that's important to me about diversity is the actual community that we're building needs to be built out of a diverse set of people. So that's diversity across gender, race, age, sexuality, et cetera, where we're trying to take on a broad set of perspectives. Because ultimately what we're building together is a community, collaborative community, and the strength of that community is the strength of the different human trust relationships that we build as this web that is resilient to change and is what's really fundamentally going to sustain us as we grow and satisfy these new use cases. So switch gears to a definition of what is OpenStack. OpenStack over its history has had many different attempts at sort of defining whether it's DEF-core or the Big Tent or TC badging, all these different mechanisms for looking at what is OpenStack. OpenStack is first and foremost a large set of projects and a vast community around those projects. Those projects are largely geared towards building a cloud, but it's certainly more diverse than that. We have a number of projects that are building CI/CD system for OpenStack, which has really been one of the impressive feats of or side effects of the OpenStack community is not just the cloud itself, but how we build it, how we develop this technology together. But I think it's important to look at from the perspective of the rest of the industry. having some clear, bright lines around what OpenStack is really helps us collaborate. So the picture that Jonathan had of collaborating with the rest of the industry, we can't do it alone. There's a natural tendency to want to take it all on, and we need to recognize what are we doing, what's our core competency, and where are we collaborating with external communities. Some concrete examples are with the OP and FE community, where we're working very directly with a set of service providers trying to understand their unique market requirements and have those fed into the OpenStack community. Clear lines of ownership is what facilitates some of that collaboration. Similarly, with the Cloud Native Computing Foundation, a group that's 100% focused on that application developer perspective. They're really focused on application orchestration, things that rely on some underlying infrastructure. They don't really want to go and build an infrastructure management system. That's a great opportunity for us to collaborate with the rest of the industry in defining our role in this stack. So I wanted to take that and move towards this discussion around containers. So there's a lot of what is containers, how do they relate to OpenStack? Are we using containers to deploy OpenStack services? Are we using OpenStack to deploy containerized services as applications on top? Of course, the answer is yes. So what are we doing together with OpenStack and containers? And is this a tension? Is there value that we're building together as two separate communities? I just wanted to look at that a little bit with you guys. So first of all, from the perspective of a virtual machine, what might be some core issues with a VM? If you think back to that persona that we had, an operations person and an application developer, there's some unclear lines of ownership within the virtual machine where at one layer, the virtual machine may be a gold image. It's being security patched by some operations team. At another layer within the same image, you have your application logic, things that the app dev team is responsible for. So there's a little bit of confusion over ownership of what goes into the VM. And this is something that gets exaggerated in a cloud. So you've got tons of these virtual machine images, and you've got a lot of different groups owning some similar resources. And certainly that becomes like a bottleneck for how do we manage this particular resource. This is just saying things get complex, and really with complexity, one of the tools we have to manage complexity, since we're sort of, as humans, we have limited capacity to manage complexity, one of the tools we have is things like automation or potentially just simplification. We'll give you a restricted view of the world, and that will manage our complexity. So that's going to sacrifice flexibility. You could be really prescriptive about what goes into the virtual machine, and that's sort of the birth of shadow IT again. You've got developers wanting to do something, and it doesn't fit within your process. You're being inflexible. Inflexible means developers are impatient. They're going to find a creative way around that. And ultimately, you're trying to enable developers to produce applications in this agile way. So you want to make sure you're enabling them with the right tool set. So how can we look at separating concerns so that we clarify ownership in the stack? And this is a place where containers are actually really valuable. So with containers, you can really focus the application and the direct application dependencies in a deployment or in a container, but in a package that's really localized to the application-specific logic and the application developer who understands that piece. You can then separate from that the orchestration of the application. So now you can have a mechanism, automation, tooling around managing a collection of containers, and that's a nice separation of duty. So it's clear who owns, whether it's the agent or the scheduling policy or whatever it is, who owns what at each layer. And then clearly underneath that, we have infrastructure that's providing the access to the raw resources compute storage network. So this is a nice way to look at how we could break apart that different views of the cloud from the operator's view and the application developer's view, those different personas each having some space where they retain autonomous ownership so they can make their own decisions without being stuck by the request queue into some other group. Containers, from our perspective, are an operating system technology. We've been working on this in the Linux community for about a decade. So with C groups and namespaces, we've had the primitives. We've added, some basic automation around that and made Linux containers, and then something like Docker really helped developers take advantage of the low-level primitives that have been sitting in the operating system for quite some time. The fundamental difference here is the packaging and the isolation mechanism around the application. So it's still an app running on an operating system. It's just isolated and confined within a container, which may actually be able to be given a unique IP address. So you're given these nice building blocks for building a scale-out distributed application. So I think I've talked through some of this, but one of the interesting values of the container is helping separate out those ownership concerns. We now understand who owns what in the stack, and that means we can operate more efficiently within our domain. At every layer, introducing automation is a key to improving your speed. Part of improving your speed means you can make iterative changes, and with iterative changes, you can really measure the impact of a change and have high confidence that when you're actually making a change, it's a positive change, and it's not something that's going to create a negative impact on your application or underlying infrastructure. And generally, we're trying to be more efficient and maybe more importantly, more effective with our tooling. So this is just a look at how we're doing this as an industry. We've got different groups focused on different parts of this problem. So there's the OCI, which is trying to define a standardized container image and runtime so that we have a variety of tools that could be built around that. We're not just using Docker in one case and AppC in another case, or Rocket in another case. We're trying to, as an industry, define a consistent format so that the orchestration layers can build around some level of standardization. CNCF is an organization that's trying to build that view of what is a modern cloud-native application. That's container-based, microservices, services available within the platform. What are some of those services? What are the sort of top-level template languages that you use to define your aggregate application? That's a whole set of people really interested in solving those problems that are looking at it from the perspective of how do we standardize some of these interfaces. If you have an application reliant on platform services and the platform services are unique to every platform, you lose application mobility, something that we spent a long time in the operating system world trying to build up around things like POSIX compliance so that you can really reliably deploy an application on a number of different platforms. And then with OpenStack, we have a clear definition for a set of APIs to allocate resources from your underlying infrastructure. So this is from the OpenStack user survey. I think Jonathan put up a similar slide showing a lot of interest in containers within the OpenStack community, and specifically Kubernetes as an orchestration system rising to the top of interest for users. This is of interest to Red Hat because this is a project that we've been involved with for essentially since it was open sourced by Google. And we see it as a really powerful application orchestration platform. It's a little bit of an eye chart, but it's really talking about how we use Kubernetes within a product that we call OpenShift. OpenShift is a combination of Docker and Kubernetes and some additional tooling around CI/CD. So as you build your application, you want to quickly deploy it, and some internal application logic. How do you route requests between different services? Ultimately, we're building up a platform and a set of tooling so that you can build a distributed application, using modern microservice type design patterns. And this is the source of change to a container image could come from all different perspectives. It could be a manual tweak or tune that you're making to the system. Could be actual code change, which is the majority of the changes that we see to an image. Could be a configuration change, adapting to a new environment, or an image change driven by some kind of a security requirement from your infrastructure or ops teams. All of these can be managed through the same automation and tool set, and this is what's giving us that ability to move really quickly and maintain some separation of duty. A little bit hard to read, but this is a Hello World program written in a number of different languages. And what you see underneath is that in any of these languages, there are a large number of security vulnerabilities that have happened over the course of the last year. This is why we care about being able to rapidly introduce new images where the ownership may be coming from the platform side rather than the application developer side. Trying to satisfy that CIO requirement to say, how can I maintain security in this infrastructure? This is just mostly talking about what I already mentioned, which is identifying these areas of specialization. So really, this is our view on how we can combine these technologies. It's application orchestration systems sitting on top of OpenStack, making use of these core services like Nova, Neutron, Cinder. In this case, we're also looking at using load balancers and DNS as a service, and all this powered by powering the hardware underneath. So I think that's it. Yep. Thank you.